Here we are again. This time, we're going to talk about how this kind of stuff that's just kind of floating around in the universe. We're not going to get too specific about the fields right now because that's more of the bubble theory. But that's how it all got to start somewhere. So we start there. Eventually, you're going to start having some loops form because polarity always seeks itself. Now we're into polarity. We always begin with polarity and we end with polarity because polarity is what causes everything to seek its own self. It's what causes water to seek its own level. It's what causes politics to seek equilibrium if they ever get there. And that's what causes little things to become larger things. These are icosahedra. Notice how many patterns you can fit into a single icosahedra. This is information coding that you can use. Think of this as a logic gate. Think of this as a description of a molecular bond, a description of a way things can go together. This one has just got the flower pattern on one side, and a sort of a different pattern on the other. And it has this series of triangles that hook it all together. Triangles and rectangles. Same thing, a different story. Different kinds of information. This one's spirals. You'll notice that this one has a spiraling thing going on, plus some color bonding. The spirals translate all the way through. How much different kinds of information. Here's another completely different one. Polarity blue on the outside, red on the inside, and it opposes on the other side. So now I know that the polarity is good. And then we see some neutral colors in the middle bonding through harmonic coherence. Once again, very interesting ways to encode information on a single surface. Another spiral. Different color arrangements. A different bonding pattern in the middle. Different photocoherence. Photocoherence is what determines the qualia of a thing. Here's one that has a negative side, an inside going the opposite direction. It has a tube running down the center that goes all the way through. And when you put the top on it, this piece will mix with this piece, and watch what happens. It becomes a bonded thing with a polarity for bonding to itself. Negative on one side, positive on the other, with a tube running down the middle to maintain coherence with interstitial fluid, for example. Here's one that has mutated and become positive on this side, negative on this side, all negative nodes on the top 5, all positive nodes on the bottom side. Beautiful egg negativity. This is egg polarity. Another negative turning into a positive. This is why there are starfish in the ocean, because stars, believe it or not, this particular pattern is something that naturally emerges from quanta, from spherical structures. When you use triangles, you get spirals and joints. Here's the triangular base. What happens there is you can still get these pentagonal caps. You'll still get the pentagonal caps that give you a change in direction. That doesn't change at all. But the spirals are beautiful. You can actually take these apart and look inside. And it all hinges on these pentagonal caps doing the work. There's the inside going this way. So when we're looking at threes, we're looking at things that move. We're looking at energy. This is like a leg. Think of this as part of a leg of something. Otherwise, you're going to get really interesting symmetries like this one. This is also a dodecahedron. It's got 1, 2, 3, 4, 5, 6 on this side. Whoop. 1, 2, 3, 4, 5, 6 on this side. This one's interesting because if you look at it from this way, you get this pentagonal shape. But if you look at it from the points, you get a hexagonal shape, the spin. This is why pentagon, hexagon symmetries are always used for hyperbolics. They always lead to something hyperbolic. Here's what happens when you start iterating a simple pattern. These are just these, but they have a bonding surface. So you can actually bond them using their own bonding surface. In this case, you can see that they're all offset to this side. Because they can't be centered, they're all offset to this side. But once again, that becomes the basis of a flower, or the basis of another undersea creature that then becomes even more complex. Now we have the mollusk. The mollusk is perfect symmetry, bilateral symmetry. The mollusk has perfect designs on each side because this is what an automata has to do. Automata, whatever they call themselves. This clam opens at a bivalve right here. We're not going to open this one because it's magnetic. Then, of course, the evolution of this turns into this, which, if I take the points off, turns into this, which is inside of here. Inside this thing is one of these things, only all round. This is one that's blooming. This is what's inside of this. You can see how one is becoming the other. As these begin to grow, they will grow into each other and become this thing. These are grown logarithmically and algorithmically. This is a logarithm where you just keep adding another layer to each one. Each one gets a new complete layer and then it stops. These are just starting to grow. The surface base is what connects it to the ground, that energizes it so that when it sits on the bottom, it's oriented upward. This is how mnemogenesis, unlike all other theories of reality, actually show you reality. Not a theory. This is not a theory. This is something that happens in nature. I guarantee you this happens in nature. because it can't not. Geometry is not optional, it's inevitable. And that's the whole point of mnemogenics and fractal field mechanics. It doesn't come from people. It comes from nature. It comes from geometric intelligence. And this is how it describes our universe to us. Thanks for watching.